there is one more concept which we would like to study related to DBMS. Is nothing but one of the variant of DBMS known as RDBMS. Now what is the meaning of RDBMS? It has some full form. Now we know what is DBMS. DBMS is Database Management System. Now what is the meaning of R? Because DBMS will have that same definition. But what is the purpose of adding that R? Let's try to understand. Now here we have R as something called as relational, and DBMS stands for Database Management System. Now we have something called as R, that's relational. We know what's a database management system now. But what is the meaning of that R? Why do you think so that R is written over there, and why the databases are known to be relational? So when I want to understand something related to a relational data over here, now what do you understand by something called as the relational? Which means there will be relations between the data. Now what kind of relations do you think so are ideally important, and what is a relational database management system? Now imagine that you're storing information related to customers, orders they have been placed, or you can say that you're storing information related to a particular e-commerce platform which has lots of things to be stored. First is they could ask you to store customers information which is there, and let's say I'm storing it in the form of ID, name, age, or let's say location, and gender. So this all information is related to what? Customers. Now I have one more information, that is orders. It could be order ID which is given, the product which the customer has ordered, and the quantity which the customer has ordered, and what's the amount being paid by the customer. So this is what? This is an orders table which I have. Now it will also have customer ID, let's say. Now there is one more set of information which I have over here is related to the products. Let's say it has product, it has the product description which is there, and let's say vendor of the product who is there, and this data is related to what? Products. And let's say if I have data related to the payments, it will have customer ID, it will have order ID, it is having payments information, payment amount, and let's say there is something called as payment status which is there, and this information is related to payments. So this entire thing belongs to a database of e-commerce. So I have this entire thing based on a database of e-commerce. Let's say, just a second. Now, do you think so that all this information which I have, which I want to store, could be stored in one table? If I try to store all of them in one table or as one set of information, it will become very complicated. For me to scroll n number of times to the different table, it will be very complicated for me in order to analyze the relation between them. It will be very complicated to me if I want to maintain the consistency of the data. So there could be many challenges faced when I am storing entire set of information in one table. So in order to lower down those challenges, what I could easily do is I could convert or create multiple tables of the same information. Now how I could possibly do is, let's say I'll create information over here. So imagine this entire thing is my e-commerce platform. So this entire thing is having data related to the e-commerce platform, and I have one table. That's the very first table which I will store over here. That's this. Let's say this is the table which I am storing, and let me change the color over here. So what kind of information I would like to store is, just a second. What kind of information I would like to store over here is that this is having what ID, this is having what name, this is having what age, this is having what location, and let's say I could say that this is having what gender. So let's try to adjust it, or let me bit bigger, or let me remove the text, and just a second, let me remove this text and write it down properly. So let's say I have ID, I have name, I have age, I have location, and I have gender. So this is one thing where the data is stored, and let's say I create that this is in the form of this table. Now this data is related to what? This data is related to customers. Now similarly, I have something related to this. Let's say this data or this information is related to orders. Now I have this, and this is having customer ID, this is having order ID, this is having product, this is having quantity, this is having the amount, let's say quantity and the amount which is being paid. So this is which table for me? Orders. And let's make this table as another set of information which is there. I'm trying to create one more table over here. That's this, and I create it as products. So what do I have? I have product, I have description, and I have what? Vendor. So that's another thing, and I created in this manner. And this table is related to what? Products. And I have one more table which is possibly here, which is related to payments, and I have customer ID, I have order ID, I have the amount which is being paid, and I have the status. So this is how it is there, and this table is known as payments. Now why I am particularly storing the information in tables? Why I didn't choose any example apart from tables? So one thing to remember, that whenever relational as a word will come into consideration, the data needs to be in structured format. Yeah, you heard it right, that the data needs to be in structured format. Now, as we have seen, what is the nature of data which is in structured format? It's a well organized data. And well organized data means that it should be stored in the form of rows and columns. Now why do you think so that specific nature of data is required? Why do you think so only tables as a data are considered in a relational database? So if I go and look out for a data, and if I want to say that all the 4 tables which are being created are related to one set of information, That is, they are related to something called as e-commerce. So this entire thing is related to the e-commerce side. So now all the 4 tables are what? Are individuals. They are individually being stored. But when I can say that they are related, where I create relations. Now relations would be what? Relations that this table and this table are interlinked with each other, which means they are helping us to share same set of information. So in order to do it, the relations are being created. So how I can relate a customers table and orders table? Now you tell me that in the customers table I have something called as ID. That's my customer ID. And in the orders table you can see that there is customer ID again. So if I want to say that those 2 tables are helping me to give same set of information related to the e-commerce platform. So I can say that these 2 tables are related. If I don't relate with these tables, if I don't try to create relations, the data is not having that consistency over here. The data is just individually being stored. It is not ever said that this data is related to each other. In order to say that all the 4 tables are sharing same set of information, I need to create relation. And in order to create relation, I do require over here this. So when I start creating from here, let's say I'm not creating like this, I'll create normally. So I have a relation being created, that is from this ID. So this ID needs to be what? Linked with this ID. So here you can see the ID and ID over here is trying to relate these 2 tables and trying to say that both the tables are in relation with each other. That is, if the customers are there, then and only then they can place an order. So that's the relational part which is there. We'll understand relational in more detail in the further approaches. But when I want to relate, I'm relating them on the basis of a common factor. Now what's a common factor which is observed in both the tables for me? That's my ID. The ID from the customers table and customer ID from the orders table. So that is making a relation stating that customers tables are related to the orders table. Similarly, you can see that my orders table will be related to the products table. But what kind of relation do you think so? And which columns will help me to create those relations? That is nothing but this value, that is product from here can help me to create relation. So I can say that this is how the relations are being made between my table. So product and product is helping me to relate with respect to each other. Now it's never said that I have to always use IDs. I can use a common column which is helping me to show relations between 2 or multiple tables. So here the common shared columns which can help me to create relation between these 2 tables is products. Now another thing between this and this, let's say in payments and this, I'm creating relation with the help of orders. So this could be created for me. This is how it is being created. So if you see in the entire process, a relation is being created. So this, after creating this relation, it helps me to say that even though the data is spread across in 4 tables, the data is related and helping me to say that all the data is belonging to which database? An e-commerce database, or an entity or a property to which the data belongs is nothing but an e-commerce platform. So if I don't create relations, all 4 tables are individual, but when I create relations, it will mention that these tables are related with each other. But why do you think so relations are important, and why relational as a term is used in the relational database management system, and why specifically a structured data over here? So when we have a data in the form of structured nature, you know that the data is in a specific format. All the data are following the same format of storage. So as the format of storage or the format of organizing the data is same in all the natures of data, so it becomes easy to relate with each other. Now column to column relation, you can see that could be easily and efficiently created. But let's say I had a data related to customers. I had a data related to, let's say, customers in the form of table. And I had another thing, that is an image over here. I had a table and I had an image. Will I ever be able to relate them, that there is a relation between a table and image? No, because both are not of the same pattern, both are not following the same structure, or both are not in the same manner being stored. So relation creation over here could be difficult. But what if that the data which I have is in the form of images? Let's say both the datas are images. So there is one more data where I have another image, and I want to say this image 1 and image 2 are related with each other. But how can I relate? Is there any common entity which will help me to say that image 1 and image 2 is related with each other? There is nothing to create relations between them. And that's the reason why a data which is not in structured format could not be used in my relational databases. So relational databases, as they are creating relations between the table, which will help to show that even though there are different tables being created, all the tables are relatively sharing same set of information for us, in order to show that relational databases are there. And the reason to use tables is creating relations between the tables is very easy as compared to that of a data which is not stored in a table format. And that's why relational databases are known in this way. So as we know that the traditional way of storing the data is in the form of image, so storing becomes very efficient, are in the form of table. As we know that the traditional way of storing the data is in the form of tables, so whenever the tables are in there, you can call it as a relational database management system. So let's try to understand few properties of an RDBMS. Now, one thing over here with respect to an RDBMS is the nature of database used in RDBMS is structured data. So the nature of data which will be used in an RDBMS is a structured data. Now in this, it is also known as relational databases. RDBMS stores data in a relational manner, that is, the data is related to each other. That is, the data which I have stored is related to each other, as we can see in the above example, where the data, even though they are shared in different tables, I have shown that all of them are related to each other. Now if I want to explain that the schema. Now what is the meaning of schema? Schema is nothing but the representation. So the schema of the data is fixed. Now what is the meaning of that? That the nature of the data or the representation of the data over here is fixed, that is in the form of rows and columns. So that is in the form of rows and columns. So the schema or the representation of data is fixed in the form of rows and columns fourth, if I want to see over here, that is SQL is a primary language. Now, what is the meaning of SQL being a primary language? Primary means the main language over here. Now, SQL, we will be understanding what is SQL, but SQL is a language which is common in all the databases which are there. So, SQL is a primary used language over here, or I can call it as SQL as a common base language. So, fifth, that is examples of an RDBMS. Now, what are the example of an RDBMS? We have MS SQL, we have Oracle, we have MySQL, we have PostgreSQL, etc. So, these are some examples of an RDBMS. So, let's recollect what did we study in terms of RDBMS. Now, RDBMS stands for Relational Database Management System. Now, the word relational over here seems to be when the data or the information which is being stored into the database is related to each other. And in order to create those relations, the nature of the data needs to be fixed. So, in a relational database management system, the nature of the data which is stored is in the form of structured. That is in the form of rows and columns. So, why the data stored in this is structured? Because creating relations between a structured data is very easy and it's very reliable, and that's why the nature of data which is used over here is structured. Now, as all the RDBMS will use structured data stored in them, so the nature of them is same, and the language which will be used to communicate with all of them just a second. As the nature of data over here used is same, so the common language which is used in order to communicate with those databases is same. That's why SQL is known as a primary source language. So there are few examples of an RDBMS which is known as MS SQL, Oracle, MySQL, PostgreSQL, and etc. Now, when you're using relational databases, relations could be easily created. Now, DBMS and RDBMS has that major difference. That is, in DBMS, it's not specifically said that you can create relations. Why? Because the data was not into a specific format. It could be any type of databases used. So, relations, when they are created within the databases, that databases are known as relational databases, and a platform used to handle those kind of databases are RDBMS. And few examples of those platforms are MySQL, MS SQL, PostgreSQL, and Oracle. So, this was all about an RDBMS which we have studied. So, I hope we are able to understand what is an RDBMS.